All right, we're finishing up section 3.6. This is just one example. It's on. It starts at the bottom of 216 and it goes through page 217 if you want to look in the book, you know, for like extra help or whatever, and see how they do things. So let's do this. It says find the distance. That's what we did in the last thing, didn't it? We found the distance between what? A line and a. Do you remember? A what? A point. That's right. A line and a point. This time we're finding the distance between two lines. Not just any two lines, two parallel lines. So they're going to give you two lines. They're both parallel. We want to find the distance between those two parallel lines. And I think we kind of, I can't remember if it was this class or the other class, but we kind of made mention of that in, I don't know, did we talk about that at all? We said that's what we're going to do the next day? I don't know. Well, anyway, let's just do it. It says find the distance between these parallel lines. Yeah, it's been a whole 2 days, yeah. All right, so y equals 2x plus 1 and y equals 2x minus 3. So those are two lines. Just looking at it, without even graphing them, what can you tell me about these two lines right here? They're parallel. How do you know they're parallel? Same what? Same slope. That's right. They both have the same slope. What is the slope of both of these? It's 2. Good. So they both have the same slope. That means they're parallel to each other. So they didn't even have to tell us they were parallel, did they? Now they did, but they didn't have to because I looked at it and I was like, hey, the slopes are the same. So first thing we're going to do is we're going to graph them both. And oops, let's put them in different colors here. All right, so let's plot some points here and let's graph it. It's pretty easy to graph these two. Y equals 2x plus 1, so that means the y-intercept is at 1, right? And then the slope is 2, so we rise 2 and we what? Run 1, so it's right there. So let's connect them. Let's see if I can connect them. I don't know, might have to move this around a little bit. Let's see, like that. Move this around, like that. Oops. Let's try this again. I got a better way. Let's do this. Let's just start from here, and then I'll just extend the side out. That'll work, huh? There we go. Oh, close. Sorry. I know it's really close, and I'm being a little OCD on this, but that's okay. Doesn't that look much better than it did before? All right, let's do another one. Let's go make this one purple. All right, so 2x minus 3. So let's do the same thing. Let's graph this. 1, 2, 3 is the y-intercept, and the slope is the same thing because it's parallel. So rise 2, run 1, and we'll draw a line between these two. And just extend this one out a little bit more. Okay? Are we good so far? Pretty easy. Now, let's make this, I don't know what color you want to make this one. Green? Good. Nobody talking to me today again? Monday morning, is that what it is? First period Monday morning? Okay. All right, what we're going to do is we're going to find the distance between these two lines right here. So, let's think about it. Where would the distance be? Would it be from here, this end to this end? Would it be from here up to here? What would the distance be? Somebody give me a key word that we've been talking about as far as distance goes. Dean, you know it, say it. It's perpendicular, exactly right. Okay, it's a perpendicular line between these two. Now, where can we put that perpendicular line? Can I put the perpendicular line for from here to here? Yeah. Sure. Okay, but there's a problem though. If I put it there, now you could put it there, all right? I made that thing green, didn't I, when I did this? Let's go back to purple. Okay, there we go. If I put this little green line, can you even tell the difference between the colors up there? Yeah. Not much, can you? If you look on the computer screen, you can tell. Up on the big screen, it's hard to tell. But anyway, this little tiny line right here, that's the perpendicular distance. A problem with using a line like this is, look, I have no idea what that point is right there doing. And I have no idea what that point of intersection is right there. In order to find the distance of a line, what do I need? I need 2 points, correct? And I don't know either one of those points. So that's probably not a great place to pick to put that perpendicular distance in there. It would be really nice if at least one of the points I actually knew, right? Because I didn't know this point or this point, did I? When I put that perpendicular distance. Jacob, you with me? All right, well, keep your head up, please. So let's take a look. Look, I've got a couple points. I've got a point here I know. I got a point here I know. I've got one here that I know, and I got one here that I know. Do you agree? Okay, let's do this. Let's pick either of the ones with the intercepts. because I had to find the slope. I had to go up and over to get this one. But this was kind of given to us, wasn't it? That was the y-intercept. That was positive 1. So I know exactly where that point is. Or you could use this point down here. Just to be consistent with the book, let's use the one the book uses. And they use this one right here. It doesn't really matter. All right, I could have used this point and done a perpendicular distance to here. You follow me? You could do it either way, and you're still going to get the same answer. Or I could have taken the point here and done the perpendicular distance to there. I'm just doing the one that the book does, just so when you look in the book, you'll see the same numbers. All right, so I don't know. What looks perpendicular? Somewhere around in there? I'm just eyeballing it. I don't know exactly. I can't just look at that and say, oh, yeah, that's my point right there. Because, look, it doesn't lie on one of these little grid marks, does it? So I don't know exactly where it is. And that's what I got to do. I got to figure out where that point is right there. Well, I do know something. Let's write the stuff down that I do know. I do know this point right here. What is that point? What is it? 0, -3, isn't it? So it's 0, -3. So I do know that point. What about this point? Don't know it. What am I going to call it if I don't know it? How about x and y? You okay with that? All right. I do know something else about this little tiny, it's green if you can't tell, but this little tiny line right there. What else do I know about that line? Say it. It's perpendicular, okay, and that's going to help us. Now there's a reason that I want you to know it's perpendicular. Because what do we know about this? This is purple right here. What if I turn all the lights out? Can you tell the difference in the colors?
Yeah.
Does that look better?
Yeah.
Okay. You're not going to fall asleep on me, are you? Is that enough light to write? Are you okay? You sure?
Yeah.
Okay. We'll keep it like that. I don't want to do that too often because I know you're going to be nodding off. Because I got some nodding off already. All right, so anyway, let's take a look. So what do I know about this purple line? I know the what? I know the slope. What's the slope of that purple line? It's 2, okay? Well, big deal. How does that help me? Well, it helps me because that tells me the slope of this little green line right here. And what is the slope of the green line if the purple one is 2? -1? Where'd you get -1 from? It's -2? Thank you. -1/2. You flip it, you do. The slope, it's a 2. This is 2 over 1. If you flip it, you don't get a 1. What do you do? What do you get? You get a half, right? And you got to take the opposite sign, so it's -1/2. So you said it right. You do flip it, but when you flip it, you don't get a 1 out of that. You get it 1/2. Everybody with me? So now I know the slope of that little green line right there. So how in the world does that all help me? Well, do you remember what we did in the other problems? If I can get that to turn to black. What did we do? I got the equation of both of these lines. I got the equation of this line. I got the equation of this line. What I want to do is I want to actually find the equation of this green line. So what I'm going to do, since I'm trying to find this point right here, I want to find the equation of the perpendicular line, and I want to find the equation of the red line. Well, guess which one I already know?
Red.
The red one. I already know the red one, don't I? What is it? It's this right here, isn't it? Okay, that's the equation of the red line. What I want to do is I want to find the equation of this little tiny perpendicular green line. So how am I going to do that? Well, check it out. I know a point and I know a slope. Is that enough information to find the equation of that line? Yeah. Absolutely. So let's do it. So actually, let's do this in green since that's a green line. Which green did I use? I think that one. All right, so let's find the equation of it. So y equals mx plus b. And let's put some stuff in here. Do I know my x and my y? Sure I do. I know a point on that green line, don't I? What is it? It's 0, -3. So it's 0. I'm sorry. Let's not write it like that. Yeah, let's put 0 equals m. Do I know the m to this? It's -1/2, isn't it? Times x. What did I say the x was? I'm sorry. Stop me, please. My goodness. See, I'll blame it on being Monday morning and raining. Probably like the worst scenario ever, isn't it? To learn geometry. It's raining, it's Monday, and it's first period. Okay, but let's try to fight through that. And I got to fight through that myself. What is the y? The y is not 0. What is it? It's -3. That's my bad. All right, and then m was what? -1/2 times the x, which is 0 plus what? B. All right, see that? So let's figure out. Yeah, why did I even do that? I knew that already. I didn't even have to go through that. I could have told you already because you looked at it and the y-intercept was -3. Yeah, you could have gone through that. Oh my goodness. I'll blame it again one more time. It's probably my last time though. I can blame it on Monday morning, can I? Alright, so B is -3. Did I really have to go through all that math? No, because I could have just looked at that thing and saw the y-intercept was -3, and for some reason it just slipped my mind. Alright, so let's write the equation of the green line then. So it's y equals, what is it? The slope, -1/2 x. What's the y-intercept of that little green line? It's -3. Alright, so there we go. My goodness. We good so far? Alright, so I found the equation of the green line. The equation of the red line is this one right here, 2x plus 1, y equals 2x plus 1. What I want to do is I want to find that point of intersection. I want to find where those two lines intersect each other. I want to find the point that is shared by those two lines. Do you hear what I'm saying? I want to find the point that's shared by both of these lines right here. So what am I going to do? This is the red one. This is the green one. What am I going to do to find the x and the y that works for both of those? I'm going to put those two equations together and then use what? Either substitution or elimination. Now they're both equal to y, aren't they? Do you see that? So I'm going to take both of these lines right here. Look, this is equal to y, this is equal to y. So what did we do the other day? Probably Friday. We did substitution basically. Remember we talked about this? If they're both equal to y, then they're both equal what? To each other, correct? So that's what I'm going to do. I'm going to set them both equal to each other. So where do I have some room? I got some room about right here. So I take 2x plus 1, set it equal to -1/2 x minus 3. Let's do this real quick here. Add a 1/2 x to both sides. So if I add a 1/2, I'll just write it out. If I add a 1/2 x, it's 2.5, isn't it? What's 2.5? No, we don't write it as a decimal. We'll never write it as a decimal. What do we write it as an improper? I always write these as impropers. What's 2.5 as an improper? 5/2, right? Okay, so it's 5/2x. And then do what? Subtract a 1 from both sides. And what do we get over here? -4. How do we get rid of this 5/2? Yeah, do you see why it's nice to have it as a mixed or a improper fraction? Because it gets rid of, you can get rid of that fraction really easy. That's why I'm going to write it as a improper fraction. So we come over here, we multiply that by 2/5. Now, this one doesn't come out nice and pretty like a lot of those other ones do. This, what's my, what is it? It's just -8/5. Yeah, it's kind of ugly, isn't it? But that's okay. So that's what x is. Now let's solve for y. I can use either this equation or this equation to solve. Probably this red one, this top one right here would be easy to use. So let's use that one. I'm going to put it right here. So y equals 2x plus 1. So I take -8/5 and I add a 1 to it. Well, I multiply it by 2, so what do we get? -16/5 plus 1. Now, I'm adding it to something over 5, so how am I going to write that 1? 5/5, very good. And so what do I get right here? -11/5. That's what my y is. So what in the world did I just do? I found that point of intersection. I found the x and the y. It's kind of ugly, but what is it? It's -8/5, comma what? -11/5. That's what that point is right there. Now, just so we can eyeball a little bit better, what's -8/5? It's -1 and what? 3/5, would you agree? And what is this? This is -1 and, no, not 6/5. It's -2, sorry. Yeah, right. Hang on just a second. It's -2 and 1/5. Now, I'll let you do this on your own. Now, watch what you have to do now. You have to do what? Find the distance between where? This point and what? This point right here. So you know what to do now, don't you? Put it into the distance formula, and then you're finished. See, this is one point, this is another point, and you put them into this equation right here. Now, at this point, if you wanted to put those as decimals, that's perfectly fine. You're putting into this equation right here. Go ahead and put them in decimals, and there you go. Let me give you some problems to do.
Jameer Irwin, Zakir Washington,
You're doing page
Breon
219,
Bryant, Amani Jones,
and we're
Jordan
doing
Smith.
21 to 29.
Tyler Bradley. Please come to the upper school office.
All right, there it is. Go to YouTube, go through this. If we went quick and you didn't understand it, get on the computer tonight and go to it and pause it and stop it and write some notes and all that kind of stuff.